Now we're going to look at question number 2, and again use both methods, the radicals method and the fractional exponents method, to solve so that we can see which method may be more usable for you personally. There's no right answer to which method you choose. It's simply a matter of choosing the one that makes more sense, the one that you think that you can do on your own more reliably, the one that you think is in theory a bit more logical to the way of thinking that you've become accustomed to throughout your experience in algebra. So you can see how this is all relative. I simply want to give you options so that you know what works best for you. Now, in question number 2, the question or the equation that we're trying to solve is x to the power of 3/2 equals 8. This one's going to be a little bit harder to guess and check for. So even though in number 1, the first way we tried to solve it was with mental math, I don't know if in question number 2 that would be advisable. You can certainly try, of course, but I'm going to recommend that we try to use the actual algebraic methods here, assuming that this is the type of question for which a guess and check process is simply not as intuitive. Now, if we want to use the radicals method, we have to obviously be looking at an equation that has radicals. So question letter A is essentially doing a necessary part of the setup for us. It says the same equation could be expressed using a radical, so rewrite the left side of the equation in radical form. This is pretty much exactly what we were doing in the previous lesson. The idea that x to the power of 3/2 could be rewritten with that radical structure. We know that that would be the second root of x to the power of 3. The 8 doesn't need to be rewritten at all because the 8 doesn't have a fraction exponent to speak of. So when they said rewrite as a radical, we're basically implying that we should be rewriting the part with the fraction exponent. So that's the part that I want to solve. And I'll copy that into the box, into the using radicals methods, or using radicals method area. So the second root of x to the power of 3 equals 8. And now I want to think about the algebra here that I'll need in order to get rid of the radical or to use what we know about exponents. Now, there are technically 2 things that I have to get rid of here. I need to get rid of the radical symbol, and I need to get rid of the cube in order to get x by itself. It doesn't matter in what order we do this. We need to get rid of both of them, and they're technically both in the same spot in the order of operations. Technically, radicals and powers are considered exponents. So in terms of PEMDAS, it really doesn't matter which one you get rid of first. I'm inclined to get rid of the radical symbol first just because it's bigger and bulkier. So I'm going to think for a second about what the opposite of a radical is going to be. We know that the opposite of a radical is a power. Sometimes it might make sense to phrase it this way. The opposite of a root is a power. Remember how the opposite of a square root is a square power? The opposite of a third root is a third power. The opposite of a fourth root is a fourth power. So if I want to get rid of a square root or a second root, then that means I need to raise this whole equation, or at least this side of the equation, to a square power. Because the square power should cancel the square root. I'll highlight those 2 things so you can see why I've done that. Now remember, we can't just square one side of the equation. We have to square the other side of the equation too. That's just for balance purposes. So while it's on the left-hand side that I'm really doing the important part, I'm squaring it so I can get rid of the square root, or the second power to get rid of the second root. It's on the other side that I want to make sure I'm balancing by introducing the same operation. Because again, that's how algebra works. Whatever operation you do on the left, you have to also do on the right. The second root is going to cancel the second power. So that means what's left over is still x, and I still have that power of 3 that I haven't touched yet, equals, and now on the other side I have 8 squared. 8 squared is 64. So now once again, I have to think about getting x by itself, but at least this is a little more straightforward. In fact, this looks a lot like question number 1. I need to get rid of a third power. So again, I ask myself, well, how do I get rid of a power? Well, I use a root. The opposite of a third power is a third root. So I will take the third root of both sides in order to get rid of the third power. And again, I'll highlight so you can see what I'm doing here. The third root is going to cancel the third power. That leaves x by itself, which is what we wanted. And then I have the third root of 64. That means some number times itself 3 times. That would give me 64 as an answer. You can use guess and check, you can use a calculator, you can use lots of different things, but I think you'll find fairly quickly that 4 times 4 times 4 is 64. Thus, the third root of 64 is 4. So that must be my answer. Now we can always check our answer in a variety of ways. One of the easiest ways we can check an answer to any sort of algebra problem is to plug it in to a calculator and to see what we get. So if I plug in 4 to the power of parentheses 3 over 2, as it turns out, I do get 8, which is what they originally said in the equation, so we know this must be correct. Now, if that method made sense to you, and if you found in the previous problem that using radicals made sense to you, then this might be a good go-to method that you can rely upon. And if that's the case, you can skip the next video where I'll do the fraction exponents method, and you can skip straight to question number 3. You can say that using radicals is more successful. That's your method of choice. And then in question number 4, you can use that method for the rest of the problems. If you feel as though this method wasn't as intuitive, or if you just want to give both methods an equal shot before you make your decision, then in the next video, I'll resolve the problem using the fraction exponents method, and you can decide for yourself which way is best.